Hey guys, these are the topical questions for sequences and series in Ibdp Maths AHL. I've listed three questions, all from 2021 papers. So let's get started. Consider an arithmetic sequence where U8 equals to S8 equals to 8. Find the value of U1 and the value of the common difference D. If S8 is equals to 8, then n upon 2 a, which is the first term, plus n minus 1 into d. This is the formula for the sum of all terms in an arithmetic sequence. We know that S8 equals to 8, so the sum of all 8 terms equals to 8, and the n is again 8 upon 2. We do not know the first term, plus n is again 8 minus 1, and d is the difference. So 8 is equals to 4, 2a plus 7d. So 8 is equals to 4 2s are 8a, 7 4s are 28d, 4 2s are 8a, 7 4s are 28d. So this is our first equation. Next, if we have to find u8, the term u8, the formula is a plus n minus 1 into d, where a being the first term again. We again know u8. u8 is equals to 8. We do not know the first term, plus 8 minus 1 d. So 8 is equals to a plus 7d. This is our second equation. Now we will solve these equations simultaneously. So a plus 7d is equals to 8. 8a plus 28d is equals to 8 again. Multiply this equation by 4. 4a plus 7 4s are 28d is equals to 8 4s are 32, minus minus equals to minus 4a is equals to 8 minus 32, which is minus 24. A is minus 24 divided by 4. So A is minus 6. Now substituting A into the original equation. So we'll use this equation. A is minus 6 plus 7d equals to 8. 7d is equals to 14 and d is equals to 2. So the final answers is u1 or a is equals to minus 6. The difference is 2. An arithmetic sequence has first term as 60 and the common difference is minus 2.5. Given that kth term of the sequence is 0, find the value of k. An arithmetic sequence of first term 60 and common difference of minus 5. Right. So after every term, the difference between two terms is basically minus 2.5. So they have mentioned that the kth term of the sequence is 0. So UK is equals to 0. Find the value of k. So 0 is equals to first term, which is 60. I'm using the formula as a plus n minus 1 into t. So 0, 60 plus k minus 1, and the difference is minus 2.5. 0 is equals to 60 minus 2.5 plus 2 minus 2.5k plus 2.5. So 0 is equals to 62.5 minus 2.5k. Shift 62.5 onto that side. Right. Now let Sn denote the sum of the first n terms of the sequence. Find the maximum value of Sn. If they are asking the maximum value of Sn, then we need to find S25, because after S25 comes S26, which would be minus 2.5, and therefore decreasing the value. N upon 2 2a plus n minus 1 into d. So S25 is 25 upon 2, 2 into 60 plus 25 minus 1, 24, and the difference, which is minus 2.5. So S25. So S25 is 750. Moving on to the last question. The sum of the first n terms of a geometric sequence is given by this. Find the first term of the sequence u1. The thing to remember is s1 will be equal to u1. So I'll simply take n as 1. 2 upon 3, 7 upon 8 r, which is 1. This will give me u1. So it's 7 2s are 14, 8 3s are 24, 2 7s are 14, 2 8s are 24. Sorry, 2 7s are 14, 2 12s are 24. The first term of the sequence is 7 upon 12. But find S infinity. Find S infinity of a geometric sequence. Right. The formula for S infinity of the geometric sequence, a data booklet states that S infinity is u1 1 minus u1 upon 1 minus r. u1 1 minus r. Our first term, which we found out, 7 upon 12 divided by 1 minus r. The r is the common ratio between the second term and the first term. Therefore, to find common ratio r, we need to do u2 upon u1. We already know u1, which is 7 upon 12, so we have to find u2. To find u2, I'll multiply 2 upon 3 by 7 upon 8 raised to 2. Punch this into the calculator. 2 divided by 3 into 7 divided by 8 raised to 2. Answer comes in decimal around 0.5104. So we'll divide this number by 7 upon 12. Now answer is 0.875. So our ratio is 0.875. Final answer comes out to be 4.667. So 4.67 and 3 significant. Finally, find the least value of n such that S infinity minus Sn is less than 0.001. We know that S infinity is 4.67. So 4.667 minus Sn should be less than 0.001. So what's that such value of n? S infinity is 4.667 minus Sn, which is unknown. So let's consider it as x, or let's just keep it as Sn. So 4.667 minus 0.001 is less than positive Sn. Answer for this, 4.667 minus 0.001 is 4.66. 4.666, my bad. The formula for the finite number of sequence is u1 1 minus r raised to n 1 minus r our u1 is 7 upon 12, 1 minus ratio 0.875 raised to n 1 minus 0.875. After punching this into the calculator, our answer would be 63.27. Therefore, 64. I rounded off to the higher value because if I rounded off to 63, the number would be greater than 0.001. Thank you guys for watching my video.